Hello viewers, in today's class we are going to discuss one important conceptual problem from definite integrals, right? So here we have to solve the integral from -2 to 1 and signum of x plus 1 over greatest integer x plus 2 times the absolute value of x plus 3, right? So here we notice one important thing, that the integrand is a combination of a signum function and greatest integer function and absolute value function, right? So let us start, right? So here before proceeding further, let us take the definition of signum function. Now we know that the signum of y is equal to plus 1 whenever y is greater than 0, and signum of y is equal to 0 whenever y is equal to 0, and signum of y is equal to -1 whenever y is less than 0, right? So here we have signum of x plus 1, right? So if we replace y by x plus 1, we see that signum of x plus 1 is equal to plus 1 whenever x plus 1 is greater than 0, and signum of x plus 1 is 0 whenever x plus 1 is equal to 0, and signum of x plus 1 is equal to -1 whenever x plus 1 is less than 0, right? Now this inequality gives us x is greater than -1, and this equation gives us x equal to -1, and this equation gives us x is equal to x is less than -1, right? So this is about the signum function, right? And the absolute value function, that is a mod of x, is equal to plus x whenever x is greater than or equal to 0, and minus x whenever x is less than 0, right? Okay, and the third function is the greatest integer function, which is equal to greatest integer less than or equal to x, right? Okay, now here the limits of integration are from -2 to 1. So let us consider the real number line. So here we have -infinity, here we have plus infinity, right? And we see that here when we have x is equal to -1, then the value of signum of x plus 1 is equal to 0, right? And the limit of integration, that is the lower limit, is -2, which lies somewhere here, and the upper limit is 1, which lies somewhere here, right? And between -1 and 1 we have the integer 0, right? And this integer 0 will be utilized for this greatest integer function, right? So now we see that whenever x is greater than -1, so this is the interval, or this is the part of the real number line where x is greater than -1, and this is the part where x is less than -1, and the breaking point, or the point where we have to break the limit, is -1, right? Okay, so now here let us consider the signum function of x plus 1 as phi of x, right? Okay, so now this integral I can be written as a sum of three integrals, right? I1, I2 and I3, and let us see how we can write this integral I as a sum of three integrals, right? So the first one is from -2 to -1, right? So the first one is from -2 to -1, and the second integral is from -1 to 0, and the third integral is from 0 to 1, right? Okay, and here we can write our integrand. So for signum of x plus 1, we can write the function phi of x, right? So this is just the notation, and we have phi of x over greatest integer x plus 2 times of mod x plus 3, right? And here again we have phi of x, greatest integer x plus 2 times mod x plus 3. Here we have dx, here also we have dx, and here we have phi of x divided by greatest integer x plus 2 times of mod x plus 3, and here we have dx, right? Okay, so now let us take the greatest integer function. Now we see that whenever x it lies between -2 and 1, then the value of greatest integer x is equal to -2, right? This is due to the definition of greatest integer function, right? We can also verify it, because if I take, say, x is equal to -1.5, because -1.5 it lies between sorry, here we have -1, right? So whenever x is equal to -1.5 lies between -2 and -1, then the value of greatest integer -1.5 is greatest integer less than or equal to -1.5, right? So the value is -2, right? Okay, and similarly when x lies between -1 and 0, then the value of greatest integer x is equal to -1, and when x lies between 0 and 1, then the value of greatest integer x is equal to 0, right? Okay, let us take the mod function, right, which is the absolute value function. Now here we see that whenever x lies between -2 to -1, then the value of mod x is equal to minus x, right? So because when x lies between -2 and -1, right? So this is also due to the definition of greatest absolute value function, because all the values of x which lies between this interval are less than 0, right? And when x lies between -1 and 0, then again the value of absolute value function is equal to negative x, right? And when x lies between 0 and 1, then see here all the values of x are positive, so we'll utilize this definition. So the value of mod x is plus x, right? Okay, now let us see the signum function. Now here when x lies between -2 and -1, right? When x lies between -2 and -1, then all the values of x are less than -1, right? So here phi of x, which is signum function, is equal to -1 whenever x lies between -2 and -1, and when x lies between minus 1 and 0, then the value of x is greater than minus 1. So due to this definition, phi of x has value plus 1, right? And whenever the value of x lies between 0 and 1, then obviously all the values of x are greater than minus 1. So again we have the value of signum function as plus 1, right? So now once we have established the values of a signum function, absolute value function, and the greatest integer function in the given interval, we can easily integrate these functions. Now therefore the first integral I1 is from minus 2 to minus 1, and here we have for phi of x we have minus 1, and for greatest integer we have minus 2, and for the absolute value function we have minus x plus 3, right? And here we have dx, right? And in the second integral we have minus 1 to 0, and for phi of x we have plus 1, and here we have dx, and for this greatest integer function we have minus 1, then we have 2 times of mod x, which is equal to minus x and plus 3, right? And in the third integral from 0 to 1, phi of x is equal to plus 1, and for greatest integer x we have 0, and plus 2 times plus x, because the mod function is plus x when x belongs to 0 to 1, and plus 3, right? So now these are the three integrals which we have to evaluate. So now viewers, we can rewrite these three integrals as these. So we have minus 2 to minus 1 minus dx over 1 minus 2x, because 3 minus 2 is 1, minus 2x, then we have 3 minus 1 2 minus 2x, and then we have 3 plus 2x, right? Now we can integrate these three integrals by making use of an important result, which says that dx over say a plus bx is equal to 1 over b log of a plus bx, right? So this result would be used to integrate these three integrals, right? So now we have I, and here we have the negative sign, and we have 1 over 1 minus 2x, which is of this form. So we have minus 1 over 2 log of 1 minus 2x, right? And the limits are from minus 2 to minus 1. And the second integral is minus 1 over 2 log of 2 minus 2x, and the limits are from minus 1 to 0. And the third integral is 1 over 2 log 3 plus 2x, and we have the limits from 0 to 1, right? So now we have to simply substitute the limits, and we will take the difference, and then we will add all the terms. So now viewers, when we substitute the limits, we'll get this expression. So when x is minus 1 here, so minus and minus plus, so we have 1 plus 2 3, then we have minus 2, so minus and minus plus, so we have 2 to the 4 plus 1 5, and similarly these two terms, right? Okay, and now here we can utilize the property of log, which says that log of a minus log of b is equal to log of a over b, right? So here we have half log 3 over 5, and here we have minus half log of 2 over 4, and here we have half log 5 over 3, right? Now we can take half common, so we have half log 3 over 5 minus log half, this is 2 over 4 is 1 over 2, and here we have log 5 over 3, right? Now we can write it as half log 3 over 5 plus log 2 over 1. Now this negative sign can be converted to positive sign by taking the reciprocal, and here we have log 5 over 3, right? So here we have used log a over b is equal to minus log b over a, right? Now in these three terms can be combined by again using the property of log, which says that log a plus log b plus log c is equal to log of a times b times c, right? So here we have log 3 over 5 times 2 over 1 times 5 over 3, right? So now we have half log, and here 5 and 5 get cancelled, 3 and 3 get cancelled, so we are left with 2, right? So the value of this integral I is half log 2, which can also be written as log of square root of 2, right?